Welcome to Algebra 1, Unit 6, Lesson 14, Practice Problems. Here are graphs of functions f in green and g in blue. Each graph represents the height of an object being launched into the air as a function of time. Number 1. Which object was launched from a higher point? So the launch height would be the y-intercept. And we can see that the launch height of G is above the launch height of F. So that means G was launched from higher. Number 2. Which object reached a higher point? Well, we can see the vertex of G right here. And we can see the vertex of F at the top here. We can see that the vertex of F goes higher than the vertex of G. So F reached a higher point. Number 3. Which object was launched with the higher upward velocity? This would be determined by the slope. We can see the slope for G is really shallow, while the slope for F is much steeper. So F was launched with a higher upward velocity. And number 4, which object landed last? Well, F lands when it hits the x-axis here, but G doesn't land until it hits the x-axis down at the end. So G landed last. If you have any questions about how to interpret these types of graphs, please use class time to ask for further clarification. The function h given by h of t equals 1 minus t times 8 plus 16t models the height of a ball in feet t seconds after it was thrown. Number 1, find the zeros of the function. Show or explain your reasoning. To find the zeros, we set each factor equal to 0. So we have 1 minus t equals 0. We add t to both sides, and 1 equals t. Then we set 8 plus 16t equal to 0. We subtract 8 from both sides. 16t equals negative 8. Then divide both sides by 16, and t equals negative 1/2. So our first 0 is 1, 0, and the other is negative 1/2, 0. Number 2. What do the zeros tell us in this situation? So number 2, the zeros tell us the time in seconds after the ball was thrown, when the height was 0. Number 3. From what height is the ball thrown? I'm going to use FOIL and turn the factored form into standard form. 1 times 8 is 8. 1 times 16t is 16t. Negative t times 8 is minus 8t. And negative t times 16t is minus 16t squared. I'm going to combine the t terms, and my standard form is negative 16t squared plus 8t plus 8. The height the ball is thrown from is the y-intercept, and the y-intercept is c in standard form. So the ball was thrown from a height of 8 feet. And number 4, about when does the ball reach its highest point, and about how high does the ball go? Before I do that, I just realized I forgot the second part of number 2. Are both zeros meaningful? No. Negative 1/2 is before the ball was thrown. So it is not meaningful. Now, when we look at number 4, the ball is going to reach its highest point at the vertex. The vertex is halfway between the x-intercepts. So halfway between -1/2 and +1 is +1/4. So the ball reaches its highest point one-fourth seconds after throwing. Now, if I want to know the height, I put that number into the formula or the equation. That gives me 1 minus 1/4 times 8 plus 16 times 1/4. 1 minus 1/4 is 3/4. 16 times 1/4 is 4. And 8 plus 4 is 12. 3/4 times 12 is 9. So the ball reaches its highest point 1/4 seconds after throwing at a height of 9 feet. If you have any questions about how I solved this practice problem, please use class time to ask for clarification. If you want to use technology to double check these answers, you can use the Desmos.com graphing calculator. The height in feet of a thrown football is modeled by the equation f of t equals 6 plus 30t minus 16t squared, where time, t, is measured in seconds. Number 1, what does the constant 6 mean in this situation? So you can see that the number 6 is not affected by time. It is a number only. This part of a projectile motion equation is the starting height. So the football was thrown from a height of 6 feet. Number 2. What does the 30t mean in this situation? The part of a projectile motion equation that has the input to the power of 1 represents the initial velocity. Since we are measuring in feet and seconds, the football was thrown at 30 feet per second. That is the velocity at which the football was thrown. Number 3. How do you think the squared term negative 16t squared affects the value of the function f? What does this term reveal about the situation? In a projectile motion equation, the input squared term represents gravity. So this means gravity is pulling down on the football at 16 feet per second. If you have any questions about how to interpret a projectile motion equation, please use class time to ask for further clarification. The height in feet of an arrow is modeled by the equation h of t equals 1 plus 2t times 18 minus 8t, where t is seconds after the arrow is shot. Number 1. When does the arrow hit the ground? Explain or show your reasoning. So the arrow is going to hit the ground at one of the two x-intercepts. So first, we have 1 plus 2t as a factor. So we set that equal to 0. We subtract 1 from each side, and we have 2t equals negative 1. Then we divide both sides by 2, and we get t equals negative 1/2. That represents half a second before the arrow is shot. So that one wouldn't be when it lands. So now we use the other factor. 18 minus 8t equals 0. We add 8t to both sides, and we have 8t equals 18. We divide both sides by 8, and we get t equals 2 and 1/4. So the arrow hits the ground 2.25 seconds after it's shot. Number 2. From what height is the arrow shot? Explain or show your reasoning. To know this, we want to use the FOIL method and turn the factored form into the standard form. So we have 1 plus 2t times 18 minus 8t. 1 times 18 is 18. 1 times negative 8 is 8t. 2t times 18 is 36t. And 2t times negative 8t is minus 16t squared. Now we combine the t terms, and we have negative 16t squared plus 28t plus 18. The number only portion tells us the starting height. So the arrow is shot from a height of 18 feet. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. Two objects are launched into the air. The height in feet of object A is given by the equation f of t equals 4 plus 32t minus 16t squared. The height in feet of the object B is given by the equation g of t equals 2.5 plus 40t minus 16t squared. In both functions, t is seconds after launch. Number 1. Which object was launched from a greater height? The number only portion of the projectile motion equation represents the starting height. F of t was launched from 4 feet. G of t was launched from 2.5 feet. So object A was launched from a greater height because 4 feet is greater than 2.5 feet. Number 2. Which object was launched with a greater upward velocity? Explain how you know. In a projectile motion equation, the portion that has time or the input to the first power is the initial velocity. So we are comparing 32 feet per second with 40 feet per second. This means object B was launched with greater upward velocity because 40 feet per second is greater than 32 feet per second. If you have any questions about how I solved any of the practice problems from Unit 6, Lesson 14, please use class time to ask for further clarification.